Okay, our final video we're going to look at is the video for the properties of the cotangent function. And you notice that sine and cosine are just horizontal shifts of each other, and secant and cosecant are just horizontal shifts of each other. So you might think that this is true of tangent and cotangent, but that is not the case. They're not just horizontal shifts of each other. They are actually reflections of each other around this line, say x equals pi over 4. Okay? Now remember, they are reciprocal relationships, just like cosine and secant and sine and cosecant. So when one is getting larger, the other one's getting smaller. So that, notice that's going to make where tangent is increasing, cotangent is going to be decreasing. But once again, when tangent is 0, that's when sine is 0. Those are the places where the cotangent is going to be undefined. If you look here, that's going to be at pi over 2, negative pi over 2, 3 pi over 2. So the odd multiples of pi over 2, and so you can see the properties there. Okay. But cotangent is actually decreasing on each piece. Like tangent, it's so there's cotangent, and like tangent, it has a period of pi. And when you look at one period, if you started at an asymptote and go to the next asymptote, that's one period, and that's one connected piece where it's decreasing. The places where it touches the axis, let's see, pi over 2, 3 pi over 2, 5 pi over 2, those are when it's 0. Okay, and notice that's when cosine is 0. When sine is 0 at 0, pi, 2 pi, multiples of pi, that's when it's undefined. Not sure if I said that right just a minute ago, but there we go. And so there is the cotangent function. Let's look at its properties here. So the domain is all real numbers except for where we have these asymptotes, which are integer multiples of pi. So all real numbers except for the set of n pi, where n is an integer. The range is all reals, negative infinity to infinity. The period is pi. That's a typo. It does not have a y-intercept, so let's fix that. Should be no y-intercepts. The x-intercepts, let's see if this is right, are at pi over 2, and 3 pi over 2, 5 pi over 2, 7 pi over 2, negative pi over 2. So odd multiples of pi over 2, and that's what we have here. Of course, y is 0. And those are also inflection points. In all 6 trig functions, if they do cross the x-axis, those are also inflection points. Of course, secant and cosecant don't cross the x-axis. In this case, each inflection point is an inflection point going from concave up to concave down. It's decreasing on each of the connected pieces. Of course, it may not be decreasing from a point on one to the point on the next one, but within one piece it's decreasing. The asymptotes are at the integer multiples of pi, 0, 1 pi, 2 pi, 3 pi, negative 1 pi, negative 2 pi. And those are the places where it's undefined. And the identities we get from symmetry, cotangent is of minus x is the same as negative cotangent of x, so it has origin symmetry. So this part here, if you were rotated around, is going to look the same as that. So if you do a 180-degree rotation around the origin, it will be the same graph. Cotangent of pi minus x is the opposite of cotangent of x, but cotangent of pi plus x is the same as cotangent of x. And just for reference, remember on the unit circle, you can see cotangent as this purple length right here as we go through here, either positive or negative. Okay, so that is cotangent. And so, just once again, let's just kind of go over a couple of things very quickly. This talks about reciprocal relationships, cosine and secant reciprocals, sine and cosecant reciprocals, tangent and cotangent reciprocals. Notice only one in each pair has a co, so that may help you keep track of which ones are which. Okay, and so again, if we have tangent and cotangent, we see the reciprocals. Where are they the same? Well, they're going to be the same when the value is 1. Well, the output of value is 1 is at when we have basically an isosceles reference triangle. And if we look at the unit circle, that's at pi over 4, 45 degrees. And then at, again, over here at 3 pi over 4. Okay, now some of the, and then they're also the same here at 3 pi over 4 would be here. And then 5 pi over 4 is right here. So the ones that correspond to a first quadrant, like that one, or that one, correspond to a first quadrant reference triangle at 45 degrees, or pi over 4. Those are 1 there. Okay. Also the ones that correspond to a third quadrant angle over here, that one, and that one right there, for example. Those are 1, but the ones that correspond to a terminal side over here in the unit circle of second quadrant here or fourth quadrant here, those have to be -1. Okay, and of course those basically happen at the odd multiples of pi over 4 is where one of those two things happens. So anyway, when you get 1 or -1, its reciprocal is the same. And notice, of course, when tangent 0, when tangent is 0, cotangent is undefined, and when cotangent is 0, tangent is undefined. Similarly, secant and cosine, remember you have your reciprocal relationships there we've looked at. And so when those are 1 or -1, they're the same. And when cosine is 0, the secant's undefined. And similarly, if we look at sine and secant, sine and cosecant, those are reciprocal. So notice they meet when y is 1 or -1, and we can get that. So in all these cases, remember, we do get periodic relationships, so these things keep going on and on and on. And in particular, if you're looking at a sine or a cosine, for example, you're looking at waves here. So we have a wave. So these functions are particularly good at representing wave motions like sound, electricity, anything electromagnetic spectrum like radio waves and so forth. They're also really good at representing things that have cyclic patterns to them. So even business cycles, cycles of light and darkness of the day, seasonal cycles, many things like that. So this concludes our series of videos on the 6 basic trig functions and their properties. So you should basically have memorized what these basic graphs look like on the Cartesian graphs, and then know some of these basic properties that we had gone over here, or be able to, basically know what the graph looks like and figure those out from the graphs.